Let us see a use case on analyzing the data from the BikeShare data. The data is available from this specific URL and it has 4 CSV files. That is the station data, the status data, trip data, and weather data. I have already added these specific files as a part of my HDFS after downloading from the specific URL. It has a very good data set. It has almost like a 1.25 GB of data within the status data. So let us go ahead and analyze the specific CSV file. To do the analysis with SparkSQL, we need to create the tables. So I'm going to read the CSV file using the Spark shell and create the data frame. From the data frame, I would create the temp table, and from the temp table, I would be creating the tables. Let me log into the Spark shell. I'll use the CSV file available within the HDFS location. I'll use the read option of the Spark session to read the CSV file. I'll request the Spark to infer the schema automatically, and I'll give the option saying it has a header. It would read the file and it would create a data frame. I can check the schema of this particular data frame using the option dataframe.schema. I have the data frame, it inferred the schema automatically. I can say the dataframe.schema would give me the structure of that specific data frame. Now I would register this as a temp table, the dataframe dot create or replace temp view, and I would register that as a temporary view. From this temporary view, I would be creating the actual data. So let me go ahead and create the data as station underscore data underscore 1. Already I have the data that got created. So I'm going to create it. Just to show the demo, I'm creating once again the table. The table would get created in that specific location. The same way, I would be reading all the CSV file. That is the 4 CSV file. I'll create the data frame, register that as a temporary view, and store that as a table within the SparkSQL. The commands to create the data frame, register them, as well as create the table, I am uploading into the recordings. So this is how I'll be registering the data frames. This is how I will be creating the data frame by reading the CSV file, and then I'll be registering all the 4 data frame as the temporary view, and I'll be creating the table from this temporary view using these commands. So I'll be having all these 4 tables. Let me come out of the Spark shell. Let me get into the SQL shell, and I already have the database and the tables. I have the database, all the tables I do have. I'm going to cache these tables so that any query that I'm going to use will be much faster. That's the main intention of Spark, to have the data in memory and fire the query against the data available within the distributed memory data. I have all the data available within the cache. For example, the status data, it has almost like 760 MB of data that is divided into 12 partitions, and it is available within the memory. I'm going to fire the SQL query against this data, and let's check how the query works. I have some sample queries. The first query, I'm going to check how many long trips I do have within the trip data. So within the trip data, I have a column called duration, where all the records where the duration is more than 3600 seconds. So I do have the result, and I'm going to find the next query. I'm going to find out the different subscriber type and their count. So I'm going to check the data from this specific table, trip underscore data. I'm going to group based on the subscriber data and the count. So subscriber, this many rows, and customer, this many rows. A similar way, I have another query. I'm going to get the subscriber type and the average duration in minutes for different subscriber type. So all this data, the result, what I can do, I can take it for further visualization or further analysis to other system. I can store the result in other CSV file, or I can export it, or I can store it in another table, and that would get stored as a file within the HDFS. I can export it to the other system and do the analysis. And I can use the statement explain to find out what is the plan it's going to use to execute that specific query. So explain this specific query. I'm going to get the station ID, station name, and the number of starts by doing the join between these 2 tables. It would give me the plan how it is going to execute this specific query and get the result. Let me execute the query and see the result. So this would give me the terminals having maximum number of starts. So these are all the terminals where I do have the maximum number of start station. And I do have a little more complex query to find out the status from the status data. That is, what are all the stations having 0 number of bikes and how many such incidents it had. So this specific station had this many number of 0 bike status rating. That means more demand from that specific station or more number of bikes going out from that station and not coming in. The same way, I have some additional queries as well, selecting the bikes available as well as the number of occurrences. So these are all the values where I do have the number of bikes available, that is 6. That's the more number of status. So that means on an average, the 6, 7, 5, 8 are the frequent number of bikes available, and only this many incidents, a huge number of files were available. So this would help me to identify what is the average or the distribution of the availability of the bike across the stations. These are all the incidents. This many number of times, 6 number of bikes were available in different stations. I can check the top trips, that is the start station and the end station, the top number of trips. So from this specific station to this specific station, this many number of trips happened within this data. If you observe very carefully, all the queries, irrespective of the size of the data, it got the result very fast and quick. The reason because it is already cached in the memory and it is going to do the processing with the data available within the memory. It doesn't need to read the data. If it has to read this huge amount of data, it's going to take huge amount of time because the storage is going to be the slowest IO component in any computer environment. So this is a very good use case to understand how the data will be coming into the system and how we will be using it within the SparkSQL environment and how we can cache and expedite the query processing.